As I'm reading through this word problem example, I am thinking of my options. Plugging into the original function if it's not asking about change. Average rate of change, I'll use the slope formula, and change at an instant, I'm going to take the derivative and plug in. In the wake of the 2008 financial crisis, the number of bank failures began to fall sharply between 2010 and 2012. So there went from a lot of banks failing and going out of business to a rapid decline in that happening. Less banks are failing. The number of bank failures from 2010 through 2012 is described by this function f of t here. So we are talking about the number of bank failures, where f of t is measured in thousands of bank failures and t is measured in years, where t equals 0 corresponds to the year 2010. So you plug in years, and you get out thousands of bank failures. So if you get an answer of 2, that doesn't only mean 2 banks failed, it means 2,000 banks failures. So this is 1,000 bank failures. What was the number of bank failures in 2011? What was the number of bank failures in 2011? We're thinking, do we plug into the original, slope, or derivative? I don't see any words asking about change. It doesn't say how fast were the number of banks failing in 2011 or something like that. Or on average, how fast were they changing between 2008 and 2011. It's just asking what's the y value for 2011. We want to keep in mind that t equals 0 corresponds to 2010. So what t value is 2011? It's just 1 year later. So we're going to do f of 1, which will be 48 e to the negative 0.83 times 1. I'm replacing the t in this function here for f of t. In some calculators, you might need that whole exponent in parentheses in order for it to come out correctly. So if we plug it in just like this, and keep in mind our output is in thousands of bank failures, so we get 20.930367. It just keeps going. But remember, it's not just 20 bank failures in 2011. Unfortunately, the economy still wasn't great. You need to multiply this out by the units of 1,000, which will really just move this over 3 places, about 20,930 bank failures. In 2011. So still almost 21,000 banks failed. The next part says, how fast was the number of bank failures changing in the beginning of 2011? So we know that there were almost 21,000 banks that failed, but hopefully the rate of change indicates that maybe things were going to get better in 2011 and that less banks were failing. So let's see by taking the derivative, because I see a change word and I don't see average change between 2 years. We have change at just an instant. So we need to take the derivative, f prime of t, of our function up here, 48 e to the negative 0.83t. So I'm going to keep the constant multiple, just like if it was 48x squared, I'd bring down that power 2 and multiply it with the 48, because we'd keep the 48. So I'm going to keep the 48, but I need to take the derivative of e to the negative 0.83t. So we have e to a power that's not just x, or t in this case, so we take the derivative of the power. Derivative of negative 0.83t is negative 0.83. Derivative of the power times e to the original power. And now I can multiply these numbers out if that makes it faster to plug into your calculator. You don't have to, but it could help. 48 times negative 0.83 is negative 39.84 e to the negative 0.83. There we are measuring instantaneous rate of change. So we can plug in any year. Of course, this is given on this little interval here from 0 to 2 years. That just indicates that the strain on the economy wasn't going to last forever. We wouldn't want to plug in 2024 into this equation because what happened in 2008 isn't really impacting us in 2024 anymore. So we would just want to plug in something on this interval, which we are going to. 2011 is 1 year in. So we're going to do f prime of 1, and this equation should still be applicable. We just wouldn't want to plug in 10 years later. Everything has changed in the economy since. So that's why it's just on that little interval that this equation actually models the economy. So if we plug into our derivative here, we're plugging in for 2011, which is 1 year later. We should get negative 17.37220. It just keeps going. First of all, this is in units of 1,000, so I'll multiply it out. If it was in units of billions, I probably wouldn't multiply it out because it would not be worth it. But in thousands, this actually makes more sense to me. It's about 17,372. Remember, this is a rate of change, so it should have 2 units on it. So we're measuring bank failures per year. So is it okay that we got a negative answer? If we think about this interpretation, our slope at that instant, or our instantaneous velocity or change, is negative, which indicates a decrease. This is a good thing. We would say in 2011, the number of bank failures was decreasing, because we got a negative answer, decreasing by, and we wouldn't say negative 17,000. Decreasing already took care of that negative for us. If you say decreasing by a negative, 2 negatives will make it a positive. So we're just going to say decreasing by 17,372 banks per year. So this is a good thing. Less banks are going to be failing. That's why we got a negative answer. So there are almost 21,000 banks that failed in 2011, but by 2012, 17,000 plus banks less would be failing. So not still at 21,000, closer to being like 3 or 4,000 banks that failed in 2012 compared to 2011, because it's decreasing by so much in 2011 alone, which is a good thing for the economy. It can recover and come back after that 2008 crisis just in time for COVID to go in and make it crazy again.